Nitesh sir, I have a question.
So few minutes, okay, you will not get the sound. Okay, no issue. Yes, sir. What is the your question, sir?
Sir, while the while loop is running, suppose I am drawing this random graph and I set a threshold value that above zero point 0.8, if the signal goes, the number goes, then I should get an indicator. But the while loop should not stop, it should continue to run. So that indicator will be inside the while loop or outside the while loop?
Indicator should be inside.
Okay.
Sorry for the this problem. Earlier I was forget to uh, open the my sorry microphone. So for start few minutes, like 20 minutes, you will not get any voice. Either I will record again tomorrow morning and I will update. Now press Ctrl T and come here. There is a very beautiful concept which we call there is very beautiful concept which we call shift register. Right click and come here and take a for loop. When you will take a for loop, so you will get n. Now you can control your loop specifically n number of time. Each and every iteration it will generate one numbers, and we can read that each we can read every iteration. We can read every iteration's value. We can read every iteration's value uh, by placing the control sorry indicator inside. Either we can create a for loop, either we can create a sorry auto and external, and we can hold and display all the data in the form of the array. But suppose you want to recall your previous data. Now it is data recursion, data recall from the previous iteration to the current iteration. Suppose you want to compare the data between each and every iteration. So we need there sorry shift register. When you will right click on the block diagram, when you will right click here and you will so you will get a add shift register. Right click on the border, right click in the border, right click in the border of for loop and click add shift register. You will get add shift register here. Now right click here, add shift register. So add shift register always come in the pair. Now you can see here this add shift register arrow is upwards and this add shift register's arrow is downwards. So okay, and these are the empty. These are not defined. The data type is not defined for the shift register. So shift register can hold any kind of the data, any kind of data from LabVIEW environment. It can hold. It can hold data. It can hold commands, and it can hold instruction also. It can hold data, command, and instructions also. Okay. Now, first time it is shift register. This shift register will pass the current iteration data to the next iteration. Using this shift register, we can call the previous iteration data into the current iteration. But first, this system will take the data, then the system will give you a particular data. Suppose I want to check, okay, a difference between, okay, the distribution is equal or not for the entire setup. So right click, I can do the right click here. I can come into subtract function. I can take subtract function here. I can put my subtract value here and one value here. Distribution is, I want to check the particular distribution, and I am expecting the data should be, the answer should be -1 each and every time. Let's run the program. Okay, we are getting the, so now you can see here the data is -1. That means the distribution has been even. It's a, let's check it. Now, if I will run this program, now when if I will run this program, so we will find a very different concepts. Look at here. I am going to run the program. 0, -1, -1, -1, -1, -1. Right? We are getting this properly. 0, okay. First 0 minus 0. Then always it will give you the the past iteration data with the current iteration data. 1 minus 2, 2 minus 3. Okay, because always we will get the past iteration data, and we are subtracting with the current data. Sorry, we are dividing, yeah, subtracting with the current data. So using the shift register, you can call your previous iteration data into the current iteration. Okay, now yeah, here I am going to delete this one. B. I am going to delete this function also. Control B. Here, I am going to take right click, take add function, addition functions. Here I am taking the addition function. So now if you will try to click this in this way, it's addition function, and we'll know the data type is predefined, and that is numeric. Still, if you will connect in this way, so you will not get any data type here. Every time you have to connect the the uh, right side. Okay, the right side, this shift register. Now I want to add some data, and the data value, I want to create a data constant 2. I want to run this program only 2 times. I want to run this program only 2 times. Now let's use this program to see the data. Run. Now you can see here we are getting the value 4. Why? In the first time 0 plus 2 is equal to 2, and second time again is generating 2. 2 plus 2 is equal to 4. So if I will run one more time, so what output I will get? 4 plus 4, 2 and 8. Why it's giving us the 4? Because it's recalling the previous last data. Okay, when we run the program first time, it generates 0 plus 2, 2, then 2 plus 2, 4, and program, okay, terminate himself. When we run again, at that time, it's recall the last data which which the system passed, okay, before during the termination. At then the 4 is available here. 4 plus 2, 6, 6 plus 2, 8. If I will run one more time, so I will get the data 12. So how we can rectify? So for that you have to initialize. Right click, create constant. If you will initialize any numbers, so now you will get a perfect data each and every time. Using the shift register, you can call any previous iteration data, and you can check that data, or you can utilize the data in the current iteration. Now let's come here. I am going to delete this function here completely. Control B. Sorry. No, sorry. Let's connect. Sorry. Control Z. Control Z. Hmm. Suppose if I will connect this function like this, if the value is 10 here, and if I will make a connection like this, so now you can see Control Z. It will be give me a table for 2. Now you can see here we are getting the table for 2. If I will change this number 3, so I will get the table for 3. Now suppose I want to run 2 consecutive data. Now I want to run 2 consecutive data. Okay, and I want to check how the behavior, which means I want to add last 2 iteration data. Okay, so for the last 2 iteration data I have to increase this one. I have to just increase this one, and in that case you can I can easily add 2 data. Okay, 2 consecutive last iteration data. Suppose here if I will put a constant, numeric constant, and value should be 1, so what I will get, and take it 15, and execution highlight open run. 0 plus 1 1 1 3 5 8 13 21 34 55 9 14. Okay, now you can see this program is creating a Fibonacci series. We are able to add 2 consecutive data, 1 plus 1, then 1 plus 2, then 2 plus 3, then 3 plus 5, 5 plus 8, 8 plus 13. In this way we can also perform. So using this function we can call the last iteration data, and using this function we can call last to last iteration data. Okay, so same structure we can use, same shift register functionality we can use for the while loop. Okay, so it's shift register you can do, you can uh, do the same shift register program here. Now here I am going to close this program. Take a new VI. Now sir, look at here. Many times we are using this working window. Just I want to change here. I want to change this working environment. I don't like this functions. I want to change this working environment. Slightly change. I want to customize my environment, my working environment, which you can also do. So for that you have to come in the tools. In the tools you will get the options. In this options you will get front panel. Front panel. You have to come in the tools. You have to come into the options. Then you have to come on the category. In the category the first one is front panel. and you will get the details about the front panel. It is a category section. In this details section, in the details you will get the front panel. In this first front panel here, I am going to control style up new VIs. I am going to use the fused design. You can select the NXG in place of fused. You can select the NXG. Then panel grid. I am going to do going to close the panel grid. Deselect. I am going to deselect the front panel grid. Then come into the block diagram. Now in the block diagram, we no need to change anything. Just keep each and everything same. Then come into the environment. In this environment, I can come here. I can scroll down. Okay, you can scroll down this detail window, and there you will see the color. I don't want to use default color. I want to use the front panel also as a same white like the block diagram. And okay. Now close and open. Few things control T, sorry, control N, control T. Now you can see my front panel and block diagram both are in a one color. Now I don't want something like right click. I'm getting all this modern style huge and in your case NXG, in my case silver. It is silver numeric. It is silver numeric. It is my modern in general numeric. And here we can take the fuse numeric. Suppose you will like, okay, it's up to you. Every function will perform the same. It is completely up to you which one you want to choose. Which one, okay, which one you like more, okay, which one will give you the more, okay, which one is more appealing for you. You can choose, but I like this fuse one mostly because it looks more sober. So I can come here. Now you can see the pin. Now you can see here our pin. I am going to pin in. After the pinning, we will get the customize. Customize. You can come into the customize and change visual palette. You can click on the change visual palette. You can deselect all and you can select here fuse design and press OK. Onwards, you will get only fuse design function palette. Till you will not customize. You will get fuse design. In this way, you will get all. But default section, you will get the fuse, which I like most. Now you can see here these indicators. These are the controls terminal. These are the terminal. These are the terminal. These terminal are taking so much places during my program. If I want, so can I. If I want, so can I change it? Yes, I can change it into the icon. I can change it into the proper terminal. Look at here. It will save my more specific time. We know very well the orange color represents the numeric. So if you will get orange terminal, so that means it is showing the numeric data type. No need to worry. So for each and every time, whenever you are taking any controls and indicator, always you will get this. You will get this terminal. But we can use the small terminal. We can close the icon, view icon, and we can close the small terminal. Sorry, we can select. So for that, you have to come again to the tools. You can come to tools. You can click on the block diagram and there. Place front panel terminal as icon. Uncheck this one. Unchecked. Now, okay. In that way, whatever the controls or indicator you will take, you will get directly this small box. In that way, you can customize more for to the your front panel and block diagram.